Hey there. So I'm coming to you from my farm today, and we got a little break in the rain, so I decided to come outside and have a little conversation with you guys because the other night I was having dinner with my husband Corey, and we were talking about viruses, and shocking, right? And so I was explaining to him a little bit about what viruses are and how they work and what size they are, and I realized he really didn't know much or understand much about viruses. And my husband is a brilliant, educated guy, but I realized that most humans, Americans and otherwise, they don't have a good concept of what a virus is, how it works, the size of it. So I've been giving that some thought for a couple days now, and I'm going to tell you a little bit about myself, and then I'm going to get into some things about viruses. So first of all, let me just say that this video is not for virologists, immunologists, or molecular biologists. This is not for you people, so don't go picking apart my science. This is for the average person who really just wants to learn more about what a virus is and how it works and what size it is. So I'll tell you a little bit about myself first. So my name is Dr. Patty Barch, and I am a natural health practitioner with a very unique background. I worked for 8 years for a global biotechnology company in a biocontainment facility, mostly doing cancer research. I presented my posters at the American Association for Cancer Research. I did that for 8 years. After that, I was contracted along with two other biology professionals to write the biotechnology curriculum for the Massachusetts Department of Education, to also write the biotechnology teacher standards for licensure, but for the Massachusetts biotechnology, for the Massachusetts Department of Education. I have 2 undergraduate degrees in animal science, a master's degree in biology, and 2 doctorates in natural health. My career has been interesting, and I've been running a natural health center for 9 years now, and I also work with wellness practitioners across the globe, helping them to do things like what I'm doing now, which is to take complicated information about situations or complex medical devices and make it simple so that people can understand. So I want to help you to wrap your head around viruses. So what are viruses? So viruses are they're not really living things. They don't eat and they don't create waste, so that doesn't make them alive in the sense of the true word. But what they are is they are DNA or RNA, little pieces of it, in a protein shell, a little envelope. And so what happens when a virus gets into your body, it gets into your DNA. And I'm going to explain that in a little bit. So the virus gets into your DNA, and just like a computer virus is code, and that computer virus gets into your computer code and changes how things function, that's what a virus, that's why they called it a virus when they created computers. So a virus gets into your DNA code and changes it. So it has little programs in the virus that are for reproduction. So it makes photocopies of itself. So literally the virus gets in there, it weaves its way into your DNA, and it's like press play, and the photocopier goes, and it makes copy after copy after copy. So then what happens with the virus is your cell is cranky now, because your cell has foreign DNA in it that keeps replicating itself, and it damages the cell. So the cell sends out signals to the body that says, hey, something's wrong here, I'm in trouble. And then your body, part of your immune system, has patrol cells that they drive around the body looking for bad guys, and they pick up the 911 call from the cell that's loaded with virus, and they tag it, and they're like, this is a bad cell, this cell has to go. And then other cells in the immune system come floating around. They look for the tagged cells, and they come in, they take care of business. They destroy the cell, and they gobble up the pieces. So the best defense is a good offense, right? You want to have good immune system. You want to have cells the immune cells that work and that identify the viruses, the cells that have viruses in them. And you want to have an immune system that's going to go in and take care of those cells before you have too many of them. So what I'm not going to do in this video is I'm not going to get into natural ways to support your immune system. Why not? Why not? Because all that stuff's getting taken off social media. That stuff is getting censored. So we'll talk about that another way, another day. But the point of this video, again, is just some viral education. So summarizing that, and I'm going to get into the size of the virus. Tiny piece of DNA or RNA gets into your cell, gets into your DNA, makes copies of itself, damages the cell, immune system recognizes the damaged cell, goes in, attacks, gobbles it up, and then that should be the end of the story. Okay. So, how small is a virus? So, the most popular virus that is being talked about in the news today, I like to call it the virus that shall not be named, because of course if I name it in a social media post, the censors come through and take that stuff down. So the virus that shall not be named is between 140 microns in size. So let's average that right out to 100 microns, or 0.60 to 140 nanometers, not microns. So it's 0.1 microns, 60 to 140 nanometers. Like, so nobody can conceptualize this. This is the problem with people talking about viruses, right? We're talking about nanometers, right? And here in the US, we don't even use the metric system, which is a whole other thing that I'd love to debate sometime. So anyway, I wanted to give you an idea about how small viruses are. So in order to do that, I decided to make you a millionaire. So for the sake of this video, you're a millionaire, but we're going to start off with like whatever you make in a year. So rather than getting paid in dollars, you're going to get paid in dimes. Okay? So think about dimes. So this is how we're going to conceptualize the size of a virus. So if you have $1 in dimes, you have 10 dimes, right? Then imagine you have $100 in dimes. Then you have $1,000 in dimes. Then you have $100,000 in dimes, right? Then you have $100,000 in dimes. All right? Like, try to wrap your head around that. Because $100,000, that's $1 million, right? In dimes. A virus is the size of 1 dime. Okay? Whoa, that's tiny. So, so when you think about like how tiny a virus is, that's like 1 dime out of $1 million in dimes, right? Super crazy small. So there was one other thing I want to talk about on viruses. What was it? Oh, so remember, this is how I want you to, again, so now you think about $1 million in dimes. 1 dime is the size of a virus. So let's take that to something you might have seen like physically. Okay, 7th grade science class, you take the popsicle stick and you rub it on your cheek cells, right? And then you take that popsicle stick and you rub it on a microscope slide with a drop of water and you mix it around, right? And so because you're learning how to use a microscope and you got free cells available in your mouth. So if you remember doing this, you take the little popsicle stick, you scrape your cheek, you put it in some water, you put it on a microscope slide, you put it under the microscope. Now, the microscope lens you probably start at, maybe we'll call it 10x, right? So that's 10 times magnification. And then the eyepiece is also a 10 times magnification. So that's 100 times magnification. And when you look at those diluted cheek cells that you can't even see with your naked eye, and you look at those through the microscope, there's more cells there than you can see or you can count, right? So you have to actually zoom in to look a little closer. So then you might change it to the 40x, which give you a 4,000 magnification when you're looking at those cheek cells under the microscope. So that's when you can really see like a cell, like see a cool cell at a 40x magnification, but 40x lens plus the eyepiece at 10x, so it's 4,000 or 400x. So anyway, when you're looking at those cells, you can remember seeing within those cells there's a tiny speck, right? And that tiny speck is the nucleus. So you have like all these tons of cells, and you have a tiny cell, and then inside that cell there's the nucleus. Inside the nucleus you have 46 chromosomes, like all bundled up, tiny, tiny, tiny. 46 chromosomes are all made of DNA. I don't remember the size of the human genome, but like thousands and thousands, I don't know, maybe millions of base pairs. So anyway, the virus is a tiny, tiny piece of one of those 46 chromosomes that's inside that nucleus, that's inside that cell, that's inside of all, like, your cheek. So what I really wanted to do, make sure people understood, because I think people will often confuse viruses with bacteria. You know, bacteria go in, they use your body as food. If you have an infection in your muscle or in your skin, that bacteria is like using your nutrients and your blood and your plasma and your skin cells. It's eating them up, it's using them as food, it's creating waste, usually toxic waste, that's creating inflammation, then your immune system is trying to drive in. Viruses are a totally different deal. Viruses are just a tiny bit of DNA that gets into your cell and into your nucleus and starts making photocopies of itself. And the size of a virus is a dime out of $1 million in dimes. Okay, so again, it's 0.1 microns or 100 nanometers. Nanometers. So anyway, I just wanted you guys to just get a little bit of education about what a virus actually is, what it does, and how your immune system addresses viruses. So thank you for watching. I hope the nature sounds weren't too deafening here, but it's really nice to be outside now that the rain has stopped. So peace out, you guys. Have an awesome day.